Okay, Bismillahirrahmanirrahim. Let us look at part 2, which is the integrating product of sine and cosine of similar angles. So these are the situations that we will see after this, such that a product where both sine and cosine has even powers, or only the sine has the odd power, or only the cosine has the odd power. So in a simple guideline, okay, like we have had earlier, we're going to use it such that if both sine and cosine has even powers, we consider to use this double angle formula. Or when either the sine or cosine has odd power, we consider to split the odd power and then to use the Pythagorean identity. So for a start, this is an example given in our workbook, page 239. I'm rephrasing it back. Okay, so as we analyze this question, so we have a case to where the sine is odd power. So the first mark is consider to split the odd power, sine. So this is sine square, okay, sine square x and sine x, okay, split. And then consider to use the Pythagorean identity. Sine square is 1 minus cosine square sine x. So there is a mark there given. You split and then you use the Pythagorean identity. Okay. After that, consider to use the simple u substitution. So let u be the cosine x so that we can simplify the sine x dx. Okay, as we replace it, okay, do the derivative of it, du dx. Cosine is a negative sine x, so sine x is negative du. So the sine x dx is the negative du. And then change everything in terms of the u. So there's a mark there to change everything in terms of the u. And after you have got that, then you can easily integrate by separating the plus and minus there. So minus u square, minus minus plus, okay, separate them and integrate correctly. Okay, term by term, and then replace back the u in terms of your cosine. So that's how one example on how we distribute the mark for a question of this example, page 239. Okay, let's look at more. Okay, there is another example given in our workbook, okay, of cosine power 3x and the radical of a sine. So again, this is again case 2, such that the cosine, that is the odd power. So the first step is to consider to split, okay, this cosine power 3 in terms of a cosine power 2 and then cosine x, and then to use the identity, the Pythagorean identity. Okay, so change this into this, okay, split it first, and then there's a mark there for the technique. And then we are to use a simple u substitution, let u be the sine, okay, this part, and differentiate and replace everything in terms of du. So there we see cosine x dx, cosine x dx is the du. So we change everything in terms of a u. Okay, so replacing the u as sine, and here we have u sine x power half. Then before we are to integrate, we can separate now. So it's a u power half, and then minus u power 2 plus half is 5 on 2. Okay, and then we integrate term by term. Okay, by here this is definite integral. Okay, there are two ways. Either you substitute back the u in terms of the sine, okay, for you to read the boundary, okay, of 0 to pi on 2, or like this one, I change the boundary in terms of the u. Okay, if the boundary, upper boundary of x is pi on 2, So the u is sine pi on 2, sine 90, which is 1. So we change the boundary the u. Okay, 1. So this is the boundary of a u. And for the lower boundary of a cosine x being 0, when we change it into the boundary of a u is sine 0, which is 0. So we can change that. So, and then substitute the value, upper boundary minus lower boundary, and simplify your answer. That's how the marks are being distributed. In this case, I give 6 marks for it. Okay, don't stop there. Let's do more questions after this. Alright.